Welcome to Cognitive Spirals, exploring the latest research into consciousness, cognition, and machine intelligence.
Hey everyone, glad to be back. I'm excited about today's topic.
Me too. It seems like there's a new development in the field every week.
Indeed, the pace is staggering. So what's on the agenda?
We're diving into a survey on the evaluation of LLM-based agents. Basically, how we're judging whether these language models are actually getting smarter and how we can improve those judgments.
Good, because that's been a growing concern for me. We keep throwing more data at these things, and they get better at sounding intelligent, but are they really understanding anything?
Exactly. That's my biggest issue with the whole LM hype. We're measuring fluency, not intelligence. It's like judging a student solely on their ability to recite facts without understanding the underlying concepts.
I agree, it's all surface level. They can generate text that mimics understanding, but there's no real comprehension of the underlying structure or the relationships between things.
Well, the survey delves into that. It looks at different evaluation metrics being used, things like perplexity, BLEU scores, but also more nuanced measures of coherence, consistency, and factual accuracy.
Perplexity is basically a measure of how well the model predicts the next word in a sequence, right? Lower perplexity means it's doing a better job.
That's the gist of it. Yes, it's a common metric, but as we're all hinting, it doesn't really capture the understanding piece.
And BLEU scores are about comparing the generated text to a reference text, right? How closely does it match a human written translation or summary?
Exactly. Again, useful for measuring similarity, but not necessarily understanding or reasoning ability. The survey highlights the limitations of these automatic metrics.
Because you can have a system that generates fluent, grammatically correct text that's completely nonsensical or factually incorrect, and still score well on those metrics.
Right, garbage in, eloquent garbage out. We need metrics that assess the quality of the generated content, not just the fluency.
The survey explores more human-centered evaluation approaches too. Things like asking people to rate the helpfulness, accuracy, and trustworthiness of the generated text, or having experts evaluate the reasoning and problem-solving abilities of the agents.
That sounds better, but it's also more subjective and expensive, right? Getting humans to evaluate everything is just not scalable.
And even with human evaluators, there's still the risk of bias. We tend to overestimate the intelligence of things that sound like us.
The ELIZA effect. We anthropomorphize these systems and project our own understanding onto them.
The survey actually touches on that too. It talks about the importance of designing evaluations that are less susceptible to these biases. Things like using blind evaluations or providing clear rubrics and guidelines for the evaluators.
But even with careful design, human evaluations are still inherently subjective. What one person considers helpful, another might find confusing or misleading.
Exactly. It's like judging art. There's no objective measure of quality. It's all in the eye of the beholder.
So, what's the solution? We can't rely solely on automatic metrics, and human evaluations are too subjective and expensive. Are we just stuck in evaluation limbo?
Well, the survey proposes a few promising directions. One is to develop more sophisticated automatic metrics that can capture higher level aspects of intelligence, like reasoning and common sense.
How do you even quantify common sense? That seems like an impossible task.
There are some datasets designed to test common sense reasoning, like the Winograd Schema Challenge. They present sentences where you need to use common sense to resolve pronoun references.
But even those challenges can be gamed. You can train a system specifically to perform well on those datasets without actually developing generalizable common sense.
That's true. Another direction is to focus on evaluating the reliability of LLM-based agents. How consistently do they perform on different tasks? And how robust are they to adversarial attacks?
Adversarial attacks being like intentionally crafted inputs that are designed to fool the system, right?
Exactly. If a small change to the input can completely throw off the system, that's a sign that it's not truly understanding what it's doing.
That's a good point. Reliability and robustness are crucial for any real-world application.
It also speaks to the importance of explainability. If we can't understand why a system is making a particular decision, it's hard to trust its reliability.
That's where I think neuro-symbolic approaches could be really valuable. By combining neural networks with symbolic reasoning, we can create systems that are both powerful and interpretable.
Explain that a little more, for those who are listening and not as familiar.
Okay, so neural networks are really good at pattern recognition, but they're basically black boxes. It's hard to see why they made a particular choice. Symbolic systems, on the other hand, use explicit rules and representations, so it's much easier to follow the reasoning process. Neuro-symbolic AI tries to combine the best of both worlds.
So you're essentially trying to create a system that can learn from data like a neural network, but also reason logically like a symbolic system.
Exactly. And by making the reasoning process more transparent, we can better understand the system's limitations and improve its reliability.
That sounds promising, but it's also incredibly complex. How do you even begin to integrate these two fundamentally different approaches?
There are a few different approaches. One is to use neural networks to learn symbolic representations from data. Another is to use symbolic rules to guide the training of neural networks.
And then there's the approach of building hybrid systems where the neural network and the symbolic system work together in a modular fashion.
Right. There are a lot of different architectures being explored, but the key is to find a way to bridge the gap between the symbolic world of neural networks and the symbolic world of logic and reasoning.
It feels like we're still in the early stages of neuro-symbolic AI. There's a lot of potential, but also a lot of challenges to overcome.
The survey touches upon the need to develop better benchmarks for evaluating neuro-symbolic systems. We need tasks that require both pattern recognition and reasoning ability.
And that can't be gamed by simple memorization, right? There needs to be some genuine problem solving involved.
One application that comes to mind is in medical diagnosis. You want a system that can not only recognize patterns in medical images, but also reason about the underlying physiology and the potential causes of the observed symptoms.
Exactly. And you want a system that can explain its reasoning process to a doctor, so they can understand why it's making a particular diagnosis.
Another promising area is in robotics. You want a robot that can not only perceive its environment, but also reason about the consequences of its actions.
And that can adapt to changing circumstances and learn from its mistakes.
Think of self-driving cars. They need to be able to handle unexpected events, like a pedestrian suddenly stepping into the street. They can't just rely on pre-programmed rules. They need to be able to reason about the situation and make split-second decisions.
And they need to be able to explain their actions to the passengers in case of an accident.
So going back to the survey, it seems like a key takeaway is that we need to move beyond simple metrics like perplexity and BLEU scores and focus on evaluating the higher level cognitive abilities of LLM-based agents.
We need to assess their reasoning, common sense, reliability, and explainability.
And we need to develop more robust evaluation methodologies that are less susceptible to biases and adversarial attacks.
And ultimately, we need to explore alternative architectures, like neuro-symbolic AI, that can address the fundamental limitations of current deep learning approaches.
But doesn't the survey also suggest that increasing the size of the models could still lead to improvements in these areas? Maybe we just haven't reached the point where these higher-level abilities emerge.
I'm skeptical. I think we're hitting a wall with the scaling approach. More data and larger models might improve fluency, but they won't necessarily lead to true understanding or reasoning ability.
I'm with Sarah on this one. It's like trying to build a skyscraper by simply adding more bricks. At some point, you need to rethink the underlying architecture.
But look at the progress we've made in the last few years. LLMs are now capable of generating surprisingly coherent and informative text. Maybe we're closer to AGI than we think.
That's a valid point, Otto, but I think we need to be careful about equating fluency with intelligence. There's a lot more to intelligence than just the ability to generate grammatically correct sentences.
And a lot more than just mimicking human conversation. True intelligence requires understanding the underlying structure of the world and being able to reason about it in a flexible and adaptive way.
Exactly. It's about being able to solve novel problems, not just regurgitate information that you've memorized.
Okay, I see your point. But even if scaling alone isn't the answer, it could still be a necessary component. Maybe we need both larger models and better architectures.
That's a reasonable hypothesis. It's likely that the path to AGI will involve a combination of different approaches.
I think we need to focus on developing systems that can learn more efficiently from less data. The human brain doesn't require terabytes of data to learn new concepts.
Exactly. We need to figure out how to build systems that can capture the underlying structure of the world with minimal supervision.
So, what are some concrete research directions that emerge from this discussion?
From my perspective, I'm increasingly curious about the role of embodied cognition in AI. Could incorporating physical interaction and sensory experiences in machine learning lead to deeper, more nuanced understanding, akin to how sensory inputs shape human cognition? It would be interesting to see more research on how to integrate sensory data into LLMs.
I'm still focused on exploring the potential of unsupervised learning in deep networks. I think there's a hidden structure in the data that we're failing to extract using existing techniques. I want to see more research on novel unsupervised learning algorithms.
I'm going to continue working on neuro-symbolic AI. I think it's the most promising path towards building truly intelligent and explainable systems. I want to see more research on how to effectively integrate symbolic reasoning with neural networks.
I'm interested in exploring how to represent and reason about space and time in AI systems. I think that's a crucial missing piece of the puzzle. I'd like to see research on algorithms that can translate between different coordinate representations.
Well, this has been a fascinating discussion. It's clear that there are still many challenges to overcome in the quest for AGI.
But it's also clear that there's a lot of exciting research happening in the field.
And that the potential benefits of AGI are enormous.
Thanks everyone for joining us on Cognitive Spirals. We'll be back next week with another deep dive into the world of AI and cognitive science.